Okay, awesome. Thanks for having me, and Rahul, Derek, thanks for organizing this, but more importantly, your team did a kick-ass job, so really well done. So what is a space technology company, or sorry, what is a space data CEO doing at a space launch conference? It's pretty simple. You know, we think of it as our mandate to maximize the value of the assets that we put into orbit. At the end of the day, the more economic benefit we can get out of those satellites, the more justification and reason we have for putting more satellites into orbit. And as we see at the end, at the end of this presentation, it's a very important cycle that we go through. So I'm gonna paint a little picture for you. So it's the year 2030. Imagine the McClure Strait in the Arctic. There is a non-Canadian vessel making its way through the Arctic. It does not have its AIS responder on. It's essentially a ghost ship. There's going to be a passing radar satellite that passes by very shortly. That radar satellite, it's going to capture a metallic object roughly 200 meters wide in the McClure Strait. It's probably going to be a foreign satellite, a foreign commercial satellite. It's not going to be owned by the Canadian government. But through a company like SkyWatch or others like us, they will have access to that satellite. There's going to be an onboard processor on that satellite that is going to process the image and do the analysis and detection right on board within minutes of capture. Traditionally, that information would get sent down to the ground for analysis. Instead, what's going to happen is, because there's an agreed upon handshake between the Canadian Armed Forces satellites and this foreign commercial entity, through a series of inter-satellite linking, that detection is automatically going to go to the nearest, the next passing Canadian Armed Forces satellite. That satellite, for the purposes of this story, I'm going to call it the Polar View 1. It passes over the McClure Strait, and it's going to have the ability to capture what we call moving target indicators. So that means that it's either taking a video or it's taking a series of snapshots, and through analysis and processing, it can tell the direction at which that ship is moving, as well as the speed at which it's moving at. On board, it's also going to be able to confirm that it is, in fact, a foreign satellite. Again, no human has been involved in this situation so far. That satellite, owned by the Canadian Armed Forces, is then going to send a direct signal, communications, to the nearest drone hub in Inuvik. At that hub, they're going to be able to send out a Sky Guardian, or hopefully a Canadian equivalent at the time, which will travel to where the algorithm has predicted that ship is going to be. It's going to loiter about 20,000 to 40,000 feet above that ship. That ship is likely going to try to jam the GPS signal of that loitering drone, at which point we have a clear and hostile act. Again, at this point, a human being has not been involved in this operation. This is a fully autonomous system. Meanwhile, all of that data from all of those assets, the satellites, the drones, they will get transmitted to Ottawa, where, using a digital twin that kind of supports a common operating picture, analysts will run real-time intercept visualizations and scenario planning for how they will intercept the ship. That will eventually have a number of subsurface or surface vessels, including ships, that will get sent to intercept that ship. And eventually, its job will be to clear it out of Canadian waters. So again, we're not far away. We're talking 4 years away from having what is predictably a fully autonomous system that can both detect threats in the Arctic as well as intercept them. Unfortunately, though, the story, it's not possible today. And it won't be possible in the future unless we make a series of smart decisions about our national security. There's a number of reasons why this is impossible. One is we do not have a large ISR constellation. We do have the RADARSAT constellation mission, which comprises of 3 satellites. But when you think about a modern ISR system, we are talking about hundreds of satellites with various modalities and capabilities. But also, most importantly, and I think the largest friction point, is our systems are not built to talk to each other. They're not built with the idea of autonomy in mind. In fact, we still have a process and an operation in which human beings are the bottleneck, from information getting collected to orders and operations being sent out for capture. It's an important problem to solve. I've spent a lot of time talking to governments around the world. If you go around Canada, many departments and agencies, there tends to be one person inside of an agency or department of hundreds who actually knows how to procure satellite data. They're very proud of this. If you ask them if Canada has a problem with acquiring satellite data, they will say, no, it's a solved problem. I know who to call at the CCMEO to get my data. Literally, they know who to call. They have to call to place an order to get data. They're thinking about a problem that is solved, the problem of 20 years ago, but not the problem of tomorrow. And that's what I'm trying to spend a lot of time focusing our efforts and educating our friends in government on. Because if you look at countries elsewhere, everybody who is at the forefront, whether that is at the forefront of warfighting or at the front lines of our national security, they now expect access to data directly through the systems, the mobile, the ATAC system that they use. They're expecting data to be ready, and they're expecting it to come seamlessly. And we are right now not built to do that. So the reason why that is important is if we launch hundreds of satellites, we will not be able to maximize the value or the benefit. We will not realize this future. We will be bottlenecked on the ground with solutions that are not well fit or purpose-built for the challenges we face tomorrow. There's one other thing to note. So this is 20 years ago. 20 years ago, government had not quite a monopoly, but they owned the vast majority of assets that were in orbit. In 2006, it was about 60% of assets, with the commercial entities owning about 40%. This is roughly current state. About 87% of all assets in orbit today are commercial, 13% are government. And then if you look towards forecasting for 2030, it's likely that less than 10% of all assets in orbit will be owned by government. So what does that mean? Well, if you are building ISR systems, or if you care about reconnaissance, intelligence, or surveillance, if you are only relying on your own satellites to do that, you are leaving out about 90% of the capability that exists in the market, all to say that accessing commercial data, accessing commercial constellations is an extremely important part of your ISR strategy. In fact, in that example we talked about at the beginning, it really goes to show how commercial systems actually act as a force multiplier for your own sovereign, more classified systems. They can be used to better point where your systems should spend their time, spend their processing, and spend their imaging capacity. So I do think Canada can lead. We have excellent developments across the entire ecosystem, across the entire supply chain. We, of course, have one bottleneck right now, which is launch. I'm optimistic we have the right people working on that problem, but it's an important one. But it's also worth asking, why is it important? There's a few key reasons. A lot of people have touched on it already, and I'll touch on them again with ISR in mind. And one, of course, is freedom of action. I think Stuart, you touched on this well, which is, I like the term that what was once a geopolitical risk becomes an operational risk. And right now, without assets in space, our ability to rely on partners for intelligence is a geopolitical risk that we have to do away with. Number two, and it's the one that's most important to me, and in particular in the commercial industry, tactical resilience. I fundamentally believe that we have to move towards a world where we go from requirement understood, the space requirement that we need, to having that capability in space within days. We've heard many times today that we're right now looking at years, from design, developing, manufacturing, to eventually getting a manifest on a SpaceX rocket and getting into orbit, years. And I fundamentally believe that if you're going to have true resilience, you need to be able to measure that loop in days. It is possible, and I think we need to get there. Orbital geometry as well. Canada provides a very wide breadth of latitudes from which we could launch towards. In orbital paths, that's extremely important. ISR is not just done in polar orbit, it's done in all types of orbits, depending on the modality. And of course, end-to-end security, right? Ensuring that if we have a very specific ISR capability, say a spy satellite that we want to build, we've all heard about RCM, or I should say, I think it's probably, RCM and RadarSat, I believe. Sending this capability to a foreign nation is not exactly the most secure supply chain. And then the one that matters to me as well, another one that matters deeply to me, is the innovation loop. Fundamentally, having this capability at home, it is a pull factor for a domestic sector. It ensures that we can build constellations here at home and get them into orbit quickly as a competitive advantage, not only for national security, but also for commercial purposes. So this is my warning, and this is why we think about the downstream impacts of all of the assets we put into orbit quite a bit. Our worry is we dramatically increase our investment, but we don't take that investment and create massive output or proportional output with that investment. And if we don't create proportional output with that investment, we will not get the proportional support we need to continue that investment into space. What you'll see is your investment go down. And so we think it's fundamentally important that we continue to focus not only on what we're putting into space, but how we maximize the value that we get out of it, not only so that our armed forces and our national security agencies can realize it, but so that every Canadian can realize the economic value of it as well. Otherwise, or not otherwise, but then that loop is self-sustaining. The investment grows, our capacity grows, our support grows, repeat and cycle. So, by 2030, what I'm hoping I can come back to this stage and talk about is how the Canadian Space Launch Act has helped get Polar View 1 into orbit, along with hundreds of other ISR satellites, from Canadian territory. And we can have a sovereign ISR system that is entirely built by the North and supported by the North. So thank you very much for your time. I appreciate it.